going over where we've come from and where we're going. In a time not so long ago, drawings were created on a board with pencil and paper and erasers, lots and lots of erasers. We then moved out of the drafting board and into 2D CAD. Great improvements in efficiency, and then from there, that was followed by 3D CAD and increased efficiency. But we're still using 2D drawings. So what's next? Well, that's where SOLIDWORKS MBD, or model-based definition, comes in. SOLIDWORKS MBD is an add-on to SOLIDWORKS that helps capture product manufacturing information, or PMI. You may have heard that acronym kind of floating around out there, and it's becoming more and more prevalent in today's design industry. So we'll go over just kind of an introduction to SOLIDWORKS MBD, the creating of views and adding of dimensions, the utilization of the configurations, how we use those with model-based definition, the publishing of 3D PDFs, 3D drawings, as well as uses of assembly and exploded views, what they look like, and then we'll go over some closing with some questions and answers and some case studies. So going into SOLIDWORKS here, what we have is just kind of an overview of what product manufacturing information looks like. Product manufacturing information is all the dimensions, geometric tolerancing, as well as any kind of annotations or notes that will be used in the creation of our product. So you can kind of see here we just have the dimensions placed right on the screen. This really helps anybody that is looking at this particular model because there is no ambiguity as to what the dimensions are pointing to. Simply by clicking on any one of these dimensions highlights the feature that it's actually dimensioning. So no longer are we looking at a two-dimensional black and white drawing and wondering, exactly what the orientation of the part is and what are these callouts actually pointing to. In SOLIDWORKS MBD, that ambiguity is gone. There's far more clarity. So we can see that right here. So how do we go about creating this product manufacturing information and adding in these particular 3D, adding in these 3D views with the annotations on there? What we have is kind of a gear assembly here. This is for an underwater camera housing, and with this particular housing, we have some tightly meshed gears that require some precise placements so that the focus of the camera works correctly. We can see from this particular section view, just by kind of dissecting what's important on this part, that the location of these bolts is probably very paramount to the actual mounting of this camera housing. So let's go ahead and open up this gear plate here and start creating some of these dimensions as well as some of these 3D views. So what model-based definition is doing is that it's leveraging some of the tools that are already inside SOLIDWORKS. One of those is the Dimension Expert, the ability to easily add GD&T as well as other dimensions to your part. And it's really never been easier than this. So we can just go over to our Dimension Expert and start picking out our datums, which makes it a lot easier to understand exactly what is important to us. So just by selecting what we think is going to be our primary and tertiary, let me set my tolerance type here, primary and tertiary datums, as well as the ability to tell SOLIDWORKS that something is a compound hole, it's drilled in one manufacturing step. So we can easily do that as well. Then all we have to do is select what features that we want to add this GD&T to and what dimensions. So SOLIDWORKS is smart enough to recognize that we have a hole pattern, and then we can select that other hole there at the top. And it just adds in, like that, the correct GD&T based off our dimensioning scheme as to what we need. We also get on-screen clues as to what has already been fully defined. Anything fully defined now is highlighted in this nice green color, again adding more ease of understanding, as well as kind of jumping into exactly what is still left to be done on this particular part. We have options to better take a look at some of our dimensioning schemes by showing a flat tree view that gives us, again, all of the dimensions and positions. We can orient and go to any one of our annotation views under our annotations folder. And so, for instance, we want to better define our top hole here by just activating and reorienting that. I can now pick that dimension. In this case, it's position 5, and I can just tell SOLIDWORKS to recreate the basic dimensions, and it throws the dimensions on there for us. We notice by turning the part, though, we also get this 3-dimension, which is at the wrong orientation. Maybe we want that on the top orientation as well, and we can do that simply by just right-clicking on it and changing what annotation view we want this to be on. So with those in place, just a little bit of cleanup, and we're ready to start capturing views. So this is where MBD really comes in, is the ability to quickly and easily capture some of these 3D views. Just orient the part however you want with annotations that you want showing and say capture 3D view. Then you can just select what dimensions that you want to be shown on your 3D view, in this case just the top, and we have our first 3D view. I can then go back to the front, and we can add in some of these dimensions as well. So we have this particular part here. We can flip arrows just like we can on drawings so that they're a little bit more clear just by clicking on them, as well as add in some of those additional dimensions. So in this case, we have the position for this particular diameter here. Where is it? This one. And I can add in, again, these, I can add in those basic dimensions. So we can bring across that side dimension. Again, capturing another 3D view, this time the front. And we can start better detailing this part. Maybe we want to go ahead and create another annotation view just for the front flanged holes here. We can again do that. It's pretty easy to create these views just by inserting another annotation view. In this case, I'll say the front, and go ahead and say OK. So we have our new front view. Can rename this one. And let's start calling out these flanged holes. So again, just by going to dimensioning scheme, this time I can change it to a plus-minus scheme and polar. Since I'm calling out these holes, that can be my primary datum and my selected features. And it recognizes automatically that that's a hole pattern, saving us a lot of time of having to find all that stuff. So again, you can see it quickly moves all those dimensions onto the view. Now it can get a little bit messy because we have a lot of annotations kind of showing up on the screen here. So we'll just do a little bit of quick cleanup, and then we'll probably move some of these to another annotated view. So we have our flanged holes being shown here, and if I activate the front, we just have the front. So with this one, I can just go ahead and select the dimensions I don't want on this view. And now I have my two views here. So let me go ahead and... So with those dimensioned, I can then move on to some of the other parts of this particular piece. Maybe we want to add in some width dimensions here. we can do that as well. I can go back to ISO all dims if I want. Let's say with this one, I want to add in some kind of width dimensions. I can easily do that. Let's orient to the left side here. There we go. Orient to this side and add in some of these views. For this one, I can do this location dimension. And it's pretty easy to tell SOLIDWORKS that we are using a compound plane here, that both of these faces are on the same plane. And then from there, we can just start adding in width dimensions. And with that, we can also add in any kind of tolerancing scheme. In this case, I want to show the limits. I can then just continue adding in any kind of size dimensions that I need, as well as a material thickness. And we can do size dimensions, say for instance, this radius here and the chamfer on the bottom. We don't want to see all this stuff, so we can just go ahead and hide any of the dimensions that we don't want to see. That way we only see what's important to us on the screen. With that, I can, again, orient to my right view here. And capture this. So here's my right view. So with the right view captured, the part is coming along fairly nicely. But we have some other options that also make the dimensioning of parts a lot easier. And that is the ability to leverage some of SOLIDWORKS' built-in functionality like section views. Section views are a lot easier when using model-based definition because we're just using the section view tool that we use inside SOLIDWORKS. So if I want to say dimension these inner holes here, I can go normal to there. I can create, again, another view here, another annotation view if I would like. That will be my second one. And for this one, I can just go ahead and capture this 3D view. If I don't want to see any of this stuff, I can go ahead, hide those annotations. So I can capture this 3D view right from the start and then go in and dimension it. And this is a good time to take a look at some of the other options that SOLIDWORKS allows us to take advantage of when we're dimensioning in the context of a 3D model. So if I go to my options, this is the same as if we were inside of drawing. We can set all of our document properties as well as any kind of drafting standards that we may have. We also have some other options to make things a lot easier, like under the detailing as well as dimensions. We can change some of this stuff. And then we have some stuff with Dim Expert that allows things to be a lot easier. One of the great features is the ability to create basic dimensions. So I can turn create basic dimension on. That way, anytime we add any kind of information, SOLIDWORKS will automatically create the basic dims for us, so we don't have to do that step ourselves. So say OK. Add in a size dimension up here. Again, it recognizes automatically that it is a quantity of 2, so I don't have to do that. And I can easily add some GD&T to this particular dimension. So in this case, some true position, setting my tolerances, and calling out any datums that I need to. One of the nice things about doing this is that, say I call out a datum that doesn't apply or is the wrong datum. SOLIDWORKS is going to tell us that datum Z has not been defined. So again, this is making the application of GD&T a lot easier to do, whereas if we are in some kind of two-dimensional drawing, we're not getting this kind of live feedback here. So I can add in that dimension, and when I say OK, SOLIDWORKS has automatically added in those basic dims for me. I can then go back to this view and just say, oops. There we go. Go back to this view and just say update. And there we go. Any views we don't need, we can just delete. So as you can see, the creation of these 3D views with the annotations is a lot faster. We can also leverage some of the information that we've gotten from some of our other, when we're creating the model, we have dimensions already in there that we would normally bring across as model items in our two-dimensional drawing. We can do that here as well. With this one, I can again activate the left side here, hide any of these dimensions I don't want to see, and maybe I wanted to dimension some of this stuff. Well, we have a bunch of unassigned items that we can go ahead and show, and any of these I can just move to whatever view I need them. So in this case, I can just grab all those dimensions marked as basic and move those annotations over to the left side. Pretty easy. So with that, I can now dimension my part a lot faster. So what this allows us to do now is, because we have all this dimensioning and things in this 3D space, anyone looking at this drawing is going to have an easier time understanding exactly what we're dimensioning and what is important, as well as anyone dimensioning this part. They're going to be able to dimension it faster and add any of the information that is necessary a lot faster. The other powerful option that we have is exactly how does SOLIDWORKS deal with configurations in this kind of orientation. We can take a look at that by just going up here. I can switch to the other version. We have a version 2 of this particular part, and I can copy any dimension scheme that I've already been using, so I don't have to redo any of that work. And it copies over the dimension scheme, and it also shows us any of the dimensions that are no longer applicable. So we can easily just get rid of those and not have to worry about them. And then we're done. From here, we can now publish either to an eDrawings file or publish it to a 3D PDF. These are some kind of industry standard things that we can publish to. SOLIDWORKS comes preloaded with a bunch of templates for you to go ahead and take a look at and use, and you can customize any of these so that your drawings come out however you want them to come out. You can notice that there is custom properties that SOLIDWORKS will automatically fill out for you, as far as the things like our date, as well as any kind of revision project, and who actually designed this particular part. And then at the bottom we have previews for all of our 3D views that we captured. So what does a 3D PDF look like that once we published? Well, right here I have the part. This is what it fills out and looks like. So we have our notes built right in. We have all these material properties, a date, all that automatically filled out, who it's drawn by. Suppliers can easily comment on anything and send this right back, and all they need is Adobe Acrobat Reader. And they can send back, let's make this shorter. What is the lot size? And they just want to know how many of these they're going to have to make. And that's probably the last bit of information they would need to accurately give you an estimate on how much this part is going to cost to make. Again, one of the nice things is this is a 3D PDF. This isn't two-dimensional. We can go to all of our predefined views that we created inside SOLIDWORks, but we can also manipulate those views just like we could inside SOLIDWORks. And again, we have the ability to click on dimensions and have it highlight exactly what it is dimensioning. So pretty nice, a lot of clarity added there that allows us to avoid any kind of mistakes that are often made from trying to read 2D prints. With the ambiguity of the two-dimensional prints and just the nature of drawing in black and white with lines in 2 dimensions, mistakes can be made, they can be misinterpreted. So this takes away a lot of that ability to misinterpret something. It's really hard to misinterpret a dimension when you can just look at it and then highlight it in red, and it kind of shows you, oh, this is what that is dimensioning. So really a lot more information that we're allowed to come across with. The nice thing is that these can be generated as needed and sent out. So you don't really have to keep a database of them if you don't want to, which allows you not to have to worry about keeping a drawings database either. You're not keeping track of multiple files. All your product manufacturing information is right there in your 3D model inside SOLIDWORks. So what about taking care of assemblies? We have, again, we have our gear plate assembly that we're taking a look at. It's got some dimensions kind of already built into it that try to give us, some overall dimensions here of just gear spacing. Notice when I highlight the dimension, it actually highlights the faces that it's dimensioning to. Again, adding a lot of clarity. And we can add in any more dimensions that we may need. One of the other nice things we can do is we can take a look at some of the better section views that it has. So we have this particular section view as well as another partial section, again, just utilizing the SOLIDWORKS section view tool up here, which is a lot easier to use and a lot more powerful than the one in the 2D drawing. This makes a lot more sense. We can actually still move the parts around even though this is all sectioned out. So again, very nice part there. Maybe we want to go ahead and take a look at creating some kind of exploded view. I can come in here and activate my exploded view. I can also activate a different display state to kind of show this in glass, so it creates that. And from here, I can capture 3D views for exploded views. And I would even be able to bring in things like a bill of materials, and I'd be able to bring in bill of material and any kind of additional information like that. We can take a look at with the 3D PDF that we publish from this version. Gives us, again, a lot more information. So publishing it to my assembly-specific 3D PDF, we get a bill of materials right here. So this is really great because we can just highlight some of the different parts, and it highlights them in green on the screen, and it also does the same thing vice versa. So if I just click a part on the screen, what is this part? It highlights it in the bill of materials. Way more effective than ballooning, and there's no ability to, is that arrow pointing to the right part, or is I can't quite see behind this particular assembly. But with this, I can just move it around. I can get to all the different pieces. I can click on them, and it can highlight anything that I click on right in the screen. We also have, again, all of our 3D views that kind of show some of the pertinent information to this particular assembly. And it looks like we have a question. says, is Adobe Acrobat the only software? Sorry, you want to go? Go ahead.
No, go ahead.
All right. So the question is Adobe Acrobat the only software that a third party would need to have to view these 3D PDFs? Yes, they could use Adobe Acrobat, or they could use eDrawings, both of which are free. And then there's, of course, like Acrobat Professional, if they have that as well. But I'm just using Acrobat Reader, the free, Adobe PDF Acrobat Reader. Any kind of other PDF readers usually can handle the 3D PDFs as well. Adobe is the official supported one. But yeah, you can use eDrawings, you can use the Adobe Reader, and that is all they would need to view these files. And that's one of the big pluses to this, is that they're getting the ability to look at a 3D model and manipulate it, take a look at the parts, take a look at the dimensions. So this could be used not only by your suppliers or your engineers or design reviewers, but I've seen this implemented on the shop floor, where the people actually manufacturing the parts are able to, on a touchscreen PC or tablet computer, move the part around and get a better sense of what it is they're supposed to be, concentrating on. Where are the important dimensions? So hopefully that answers your question. Yep. So that is it. That is SOLIDWORks model-based definition. That is, how easy it is to create and document drawings. That's, again, how easy it is to use. You can see here it's got, all the buttons you need. One of the nice features is this patent-pending dynamic annotation views. So as I move the part around, any of the dimensions in that orientation kind of highlight. So you can see them highlighting on the screen, which is one of the strong suits of doing this in SOLIDWORks, is that we can take advantage of these kind of tools to, again, help clarify things. So we have, the use of our break views as well, second views, eDrawings, everything that comes with SOLIDWORks we can, again, leverage to create better, more clear product manufacturing information. And this will help us eliminate any kind of downstream errors, as well as just be more productive overall.
All right, are there any other questions out there? I also wanted to tell you, while we are waiting for questions, that excuse me, this month we do have some seminars about just this, MBD, draft site, and inspection. So you can go to our website, again, trimexsolutions.com, and you should be able to find all of our different events going on.
Yep, and just kind of to wrap everything up in closing, and to give you some information of how this is really going to help you out. What we saw is that we can bring our products to market faster, because we're no longer worrying about the creation and management of our 2D drawings, as well as the ability for vendors to quickly send back comments on 3D PDFs, allowing for the exchange of information a lot faster. And this leads to reducing the production costs, especially with the clarity of 3D PDFs as opposed to, or just PMI as opposed to a two-dimensional drawing. That clarity is really something that prevents errors, prevents misreading of a 2D drawing, since we're not working in two-dimension anymore. And then this, improved quality, accelerating any kind of ECOs that you may do. We're just getting a better overall sense of how we can leverage the power of a 3D environment, since that is what we're designing in, and use that to better go over our parts. And it's complying with new standards. So anyone that is working in Department of Defense, this is in the new MIL standard, as well as some of the new ASME standards as well. There is that are out there. So there is a push to move towards this to avoid some of the problems that we've seen with two-dimensional drafting. So to kind of quantify this for everybody, there's a company called Wasong Instrument Company, WZI. They are a global manufacturer of industrial control valve products. And they utilize SOLIDWORKS MBD. They were able to automate their production, their accelerate production. They reduced their NC code generation time by 80%. They are also able to cut their dimensioning time to 40%, which streamlined handling of ECOs. And all this is completely eliminated two-dimensional tasks and the company's reliance on paper drawings. So that's huge. One of the other companies we have is Automatic Handling Incorporated, a worldwide manufacturer of custom handling and packaging systems. They utilize SOLIDWORKS MBD, and they were able to cut their manufacturing release times again by 80%. These are big numbers. Replaced paper drawings with 3D models, which was better for production, but it also empowered the machinists and fabricators as part of the development process because they were able to better look at these parts, understand them, and quickly send back the comments so that they were avoiding having to make any downstream engineering changes. This, again, reduced administrative costs because we're taking less time to finalize our product. So a study that was conducted by the U.S. Department of Defense and some of its suppliers, they estimated that up to 1/3 of all money spent by engineering budgets is allocated to the creation and maintenance of 2D drawings during the production cycle and to support long-term product sustainment with these drawings. So this is a reason why we're moving to these 3D models with the dimensions, is that we're saving a lot of money and a lot of time just by moving to something that doesn't require one extra step, which is the creation of 2D drawings. By doing everything in the 3D model right there, we can then just quickly publish to a basic template over and over again, not have to worry about our drawings matching our parts, because everything is right there on the part. So that is kind of to wrap everything up. Any more questions? Feel free to ask.
No, it doesn't look like there's any questions right now. You were fabulous, and you had them all answered during your presentation.
Yeah, I think it's a kind of an amazing product. It's I would have much preferred to do this than to make 2D drawings.
Definitely. All right, well, I just would like to thank you all for joining us this afternoon, and I hope you have a great rest of your day. Bye-bye.
All right. Bye-bye. Thank you.